the endless silence of the Martian deserts, a solitary machine rolls across a landscape older than memory itself. Its wheels disturb the ochre dust, stirring whispers of a time when rivers carved valleys and lakes shimmered under a pale sun. And there, amid the ancient stones of Jezero Crater, something stirred. Tiny spots, barely a fraction of a millimeter across, glimmered in the rover's instruments. Subtle, almost imperceptible, yet enough to capture the gaze of every scientist peering from millions of miles away. For decades, humanity has wondered if life exists beyond Earth. Tiny specks of dust, a smattering of minerals, might carry the answer. But Mars has a history of teasing hope and disappointment, of whispers that turned to silence. Now, the Perseverance rover, a sentinel of exploration, has paused, as if holding its breath. Beneath its wheels, in the clay-rich sediments of a long-vanished lake, evidence of something extraordinary awaits. Something that could redefine our place in the cosmos. Yet even here, on this rust-colored stage, questions linger. Could these patterns be the first hints of life beyond Earth? Or are they just the echoes of chemistry, shaped by a planet's past? This is the story of what Perseverance found, of the mysteries hidden in mudstone and minerals, of tiny leopard spots that may be the footprints of alien life. And it begins quietly, in the dust of a world that has held its secrets for billions of years. The rover's wheels rolled past layers of stone shaped by eons of wind and water. Every turn, every scrape of its drill told a story written in minerals, etched into a world that had lain silent for billions of years. In July of 2024, Perseverance's cameras caught sight of something that made hearts quicken. A rock in the Bright Angel Formation, seemingly ordinary at first glance, yet betraying a subtle complexity under close inspection. Its texture, its color, the faint gleam of tiny specks, all hinted at secrets lying dormant for epochs. Perseverance's instruments, PIXL, SHERLOC, and others, began their meticulous examination. Clay and silt, fine-grained sediments that on Earth preserve microbial life, composed the rock. The rover's laser and spectrometers scanned each micro-layer, revealing the presence of organic compounds. Carbon, phosphorus, iron, bound in patterns that mirrored living processes known only from Earth. And then the names emerged. Leopard spots and poppy seeds. Tiny dots spanning barely 200 micrometers to 1 millimeter. But in their minute size lay monumental significance. The light cores of these spots reflected the surrounding rock, yet the dark rims brimmed with iron and phosphorus. Localized iron reduction, a process life on Earth harnesses for energy, seemed to have etched itself into the stone. Perseverance had uncovered something remarkable. Minerals, yes, but minerals behaving as if life had once left a mark. Vivianite, an iron-phosphate, formed here in a delicate balance. On Earth, microbes metabolize iron instead of oxygen, releasing iron-2 that reacts with phosphate in water to form this very mineral. Greigite followed a similar story, a whisper of sulfate-reducing microbes turning environmental chemistry into solid testimony. Yet the team remained cautious. Science is never convinced by appearances alone. Could heat have done this? Could volcanic activity, chemical reactions, or acidic water explain the phenomena? Each hypothesis was considered, measured, tested against the rock's composition and surroundings. A nearby sample of olivine became pivotal. Olivine weathers rapidly in acidic conditions. Its survival here cast doubt on the idea that acid alone could have produced the leopard spots. The planet, it seemed, was telling a story no one yet fully understood. With each layer of discovery came questions. Could these minerals be signs of life, or were they elaborate illusions of geochemistry? The Perseverance rover, patient and unyielding, continued to drill, scan, and store the most promising samples, each carefully logged for eventual return to Earth. The Mars sample. Return mission had become more than a plan. It was a bridge across millions of miles and years. Phase 1. Perseverance's careful extraction and storage of the Sapphire Canyon core. Phase 2. A future spacecraft would land, retrieve the samples, and launch them into orbit. Phase 3. Another craft would carry them home. $11 billion, countless years, unimaginable precision. All for the chance to finally answer one of humanity's oldest questions. And the stakes grew with every discovery. Tiny fingerprints of potential life, chirality of amino acids, carbon isotope ratios, awaited validation. L-handed amino acids, the signature of terrestrial life, or unusual isotopic distributions, could reveal a story written in the language of biology itself. Yet even with these tantalizing signs, certainty remained elusive. History reminded scientists to temper hope. Viking lander Phoenix ALH 84001. Mars had teased and deceived before. False positives were woven into the tapestry of exploration, teaching caution, patience, and rigor. Yet Perseverance's finds in Jezero Crater were different. Multiple lines of evidence converged. Organic compounds, clay-rich sediments, minerals shaped in ways that chemistry alone could barely explain. The narrative unfolded like a slow symphony. Each microscan, each spectral reading, each comparison with terrestrial analogues added notes of possibility. And yet, with every answer, more questions arose. Could life have arisen independently on Mars? Did it leave traces of a form completely alien to Earth? Could these discoveries shift the way humanity understands its place in the cosmos? The rover's journey was also a story of endurance. Miles of dust, wind-swept plains, and sharp rock faces. The robot moved tirelessly, capturing images, transmitting data across the vastness of space. In the stillness of Martian nights, when sunlight faded and the red desert became a shadowed memory, Perseverance's instruments continued their silent vigil. The discoveries were both delicate and profound. Organic rings arranged with chemical precision, minerals hinting at chemosynthesis. A planet that had nurtured conditions suitable for life, now frozen in its ancient memory. Each sample, each observation, a puzzle piece from billions of years ago, offering glimpses into the story of a world that may once have teemed with microscopic life. Every step of the mission was layered with awe, caution, and anticipation. Scientists analyzed, reanalyzed, and debated the implications. Every hypothesis was tested. Every possibility, no matter how unlikely, was measured against the evidence. And still, Jezero Crater held its secrets tightly. Yet the significance of the discovery extended beyond Mars. If life had emerged here, it suggested that life is not unique to Earth. Two neighboring planets, both capable of sustaining biology, both showing signs of chemical and possibly biological activity. Suddenly, the cosmos felt less empty, more intimate, and astonishingly interconnected. Even if the samples ultimately proved non-biological, the implications were profound. Mars preserved an ancient record of planetary evolution that Earth could not. Its crust remained largely unchanged for billions of years, a time capsule of the early solar system. By studying it, scientists could glimpse the conditions that once prevailed on our own planet before life left its indelible mark. And while Perseverance carried out its work with machine precision, it left behind questions that stirred the imagination. What if these discoveries represent the first whispers of life beyond Earth? What if tiny minerals in a desolate lakebed hold the key to understanding life itself? Mars had always been a mirror, reflecting humanity's deepest questions. And now, in the shadow of Cheyava Falls, it reflected a mystery that might redefine everything we thought we knew about our place in the universe. Mars, in its quiet isolation, has become a window into the origins of life itself. The red dust and frozen plains do more than preserve rocks. They preserve history, ancient environments, and perhaps the faint traces of biology. Every sample Perseverance collects is a page from a planetary diary, a story written in minerals, shaped by water, and perhaps by life. Imagine holding the Sapphire Canyon sample, once encased in Martian mudstone, now in a lab on Earth. Scientists would examine its structure, its chemistry, its subtle asymmetries, searching for signs that life had once touched it. Chirality, carbon isotope ratios, patterns only living processes produce, each a potential signature of an alien origin. And yet, science demands humility. Even with the most compelling evidence, even with patterns that echo earthly biology, the possibility remains that Mars is telling a story in its own language, one that is familiar yet alien. Perhaps life arose differently here in ways we cannot yet imagine. Or perhaps these rocks are silent witnesses to a chemistry that mimics life, but is not alive at all. The very act of exploration reshapes our understanding. If Mars ever hosted life, even microbial, it forces a radical reconsideration of the cosmos. Life may not be rare. It may not be unique. The Drake equation, the long-held framework estimating the number of civilizations in our galaxy, suddenly shifts. What once seemed improbable now feels almost inevitable. In the end, the question lingers: are we alone? Or has Mars already whispered an answer encoded in clay, iron, and carbon rings, waiting for patient eyes to interpret it? And if this is only the beginning, if one world shows that life can emerge beyond Earth, then the cosmos may be full of possibilities yet unseen, worlds yet unvisited, stories yet untold. Mars has become more than a neighbor. It has become a mirror. In its ancient rocks, we see the echoes of our own beginnings, a reflection of what was and what might be. And in those echoes, we sense a quiet truth. Life, in some form, may be a common thread woven through the fabric of the universe, waiting for discovery, waiting for understanding, waiting for us.